Hello, everybody. We will wait a little bit more to see if we have everybody on board. More people is joining. Okay, I think we can start now. My name is Enrique Alvarez, and I am the technical coordinator of the Ocean Prediction Decade Collaborative Center. Thank you for being here with us today. And our idea today is explore the development of ocean forecasting in the framework of the decade. And we will do this with a fantastic group of speakers. And we will do this with two different perspectives. On one hand, we will be talking about the activities developed by two key programs for the decade, which are Foresee and CostPredict. And then we will talk a little bit about the regional teams we will explore the regional perspective of ocean prediction through the presentations of the leaders of the regional teams of the Ocean Prediction DCC. So I will start this session with a presentation of myself. Sharing screen. Oops. And I will describe a little bit what we are, first of all, a little bit of context, where we are in the decade, what are the decade collaborative centers and decade collaborative office. These are the bodies of the decade that are in charge of the coordination of promoting the collaboration between different programs. There are two different types of decade collaborative centers and offices. Ones are the thematic or regional, the regional DCC, that are obviously creating collaboration in different areas of the globe. We have here, for example, the Indian Ocean. So there is very active, one of our panelists today in this Decade Collaborative Center. And then we have the thematic Decade Collaborative Centers that are related to more specific actions. It could be ocean prediction, like this is the case where I'm now coordinating the Ocean Prediction Decade Collaborative Center, data sharing, ocean observing, coastal resilience, etc. So these are more related to the thematic part of the decade, and both are talking together and both are trying to coordinate together the different programs. And the different programs is where really a lot of the action takes place. And related to ocean forecasting, there are several programs that are working together towards the development of one digital ecosystem. We have Foresee, DITO, Best Practices, CostPredict, and today we will count with presentation of two of the main ones that are CostPredict and Foresee. So before that, I will explain a little bit what we are trying to achieve at the Ocean Prediction Decade Collaborative Center. First of all, we are trying to promote, to give service to these programs to help them to achieve their objectives. And the way we are doing that is promoting ocean forecasting during the decade. So on the left, we have the ocean forecasting that we have today. We have systems. We are proud of these systems. We have been working on these systems for many years, but we must admit that they are somehow partially disconnected, and there's poor presence on those institutions that are technologically less advanced. So we want to change to a new scenario where all the systems, as I said, working together with these decade programs, where all the systems are interconnected, we have a community behind them, and we have more robust systems worldwide. The captain is the UN Ocean Decade. This is the framework where we are doing everything. We are doing that thanks to the decade actions and the concept of the digital twin. So this is where the engines are really in this analogy of the vessel, of the Ocean Prediction DCC vessel. The crew is the community that we are building around us thanks to the regional teams. And our role is the one of navigators setting the course from one scenario to the other. These regional teams that will be the focus of the second part of the presentation are really the ones that are going to promote the implementation and use of ocean forecasting systems worldwide. And we have taken the best of UNEP regional seas and GOOS regional alliances. Sometimes we are directly working with GOOS regional alliances. And we have taken the best of both worlds to create these regional teams that now they are the boots on the ground. They are our boots on the ground for the work we have to do. This work consists in support dedicated actions related to ocean forecasting, such as the programs that we have here today, identify gaps and ways forward, capacity development, and the advocacy for implementation best practices, standards, and tools. And related to that, well, these are the leaders of the different regional teams around the globe. And if you put together the steering teams, you see that we have formed a whole community that is trying to give shape to this initiative. So we have, for sure, many ways to promote ocean forecasting, and this is the way we have decided to follow. The way we have decided to follow is to work together with dedicated programs in this virtuous loop that we see here. We have this virtuous loop must start with the knowledge. The tools guide is where all the knowledge is compiled. At least it's a good start for that. It's not all the knowledge compiled for sure, but it's a good start to the world of ocean forecasting. So this is our first asset for this development. Once you know the basic things about ocean forecasting, you can start thinking about developing your system. And then we have built the architecture guide that we will publish probably this week on the OceanPrediction DCC webpage. This is a publication about to be published. And this tells you how to build the system. Then we have the operational readiness level that tells you how to operate the system. And finally, we have to integrate all this into digital twins and other services. So very briefly, to do not go beyond my time, this is how the architecture look like. It's a wiring guide on how to build ocean forecasting systems. Then we have the operational readiness level that is also going to be published really soon as a peer review paper. And this is a collection of best practices. And on top of that, we have a test that is telling you if your system is properly implemented and operated in terms of production, system validation, and product dissemination. So this is what we are going to do to promote the proper operation of the systems around the globe. And then we have the integration of all this in the framework of the decade. We are working together with the DCOs on data sharing and ocean observing to create this digital ecosystem. And we are working together with the different programs of the decade, trying to promote forward ocean forecasting around the globe. So as conclusions on my side, OceanPrediction DCC is going to work in close collaboration with the decade partners to promote ocean forecasting and its application during the decade. We have built a community around ocean forecasting that is organized in these regional teams. This community is growing, this community is being more and more active. And the first result of this effort are now visible, finally. We have, hopefully this week, published the architecture on the webpage. The URL is going to be published probably in the next month as a peer review paper. We have an atlas with ocean forecasting systems around the globe. We are starting to build a forum about this, and more ideas are going to come. So I welcome you to engage our community and register at unoceanprediction.org. And this is what I want to say as an introduction. And now I will be glad to give the floor to Fraser Davison, that will talk on behalf of VIII. Fraser is a research scientist, a manager of dynamic hydrographic product with Fisheries and Oceans Canada. For the last 20 years, Fraser has focused on advancing different aspects of operational oceanography. This includes working with many different aspects like geodesy, altimetry, gravity, tropical cyclones under a connection with gravity waves, and many other things. So I hope to meet Fraser in person soon, because we have been working together for many years, but we have failed to do that. I hope in Paris that will be the case. Fraser, now the floor is yours.
Thank you, Enrique. I'm going to share screen. Hey, can you see the screen?
Yes, everything is perfect.
Perfect. So there's a brief presentation to give you a quick overview of VIII, which is basically the decade program that OceanPredict, which is the consortium or the group, which I'll explain in a bit. The overall idea is for strong international coordination But that international coordination in part comes from, or mostly comes from the DCC, that's the architect of the whole value chain of the ocean prediction system. And our overall goal is to advance the science, the capacity, efficiency, the impact of ocean prediction systems. This we can't do alone. Yes, we can push the science and so on, but for it to be actually usable by others, whether it's fishermen, etc., we need to really collaborate as an ecosystem or as a whole team. And so we're contributing to instead of creating this end-to-end value chain, we're contributing to this seamless end-to-end ocean information value chain as the integrated and interconnected ocean prediction system component. So we're ensuring that the ocean prediction systems are impactful and relevant, but that's also done through the various different decade programs, etc., to achieve this. We definitely don't do this on our own. So OceanPredict is the international coordination mechanism, or it's an initiative of almost 10 now national prediction systems grouping together. It's been traditionally driving research and development of these ocean forecast systems, so the science behind prediction systems. And we've had an aspiration to have impact and relevance for different for people to use, or societal benefits from our prediction systems. But really, that's going to be achieved through the decade. It's something we've always aspired to, but finally, with the decade and its evolution over the next 10 years, is going to enable this further integration and also use of the forecast systems. So the vision we have in 4C is a strong international community, building the ocean prediction systems of the future, advancing the science, absolutely, behind it, but also increasing capacity, efficacy, use, and impacts of ocean prediction systems. And basically, it's what we're aiming for is a collaborative, sustainable oceanography ecosystem responsive to user needs. And again, it's something that we don't achieve on our own. We achieve through collaboration, pushing things forward from our end, but also interacting and being proactive with those interactions. So there is a need in ocean prediction systems to be more structured with standards and best practices, identified, documented, and implemented. That is happening in large part thanks again to the DCC for orchestrating some of this, or for orchestrating the framework in which we are operating and will operate. OceanPredict in the last 2 years has created this OceanPredict Operational Systems Working Group, or OPUS Working Group for short. It's the first time although we've been together almost 20 years in the ocean forecasting since 2000, we've never really had an exchange of or a working group just for the prediction systems, looking at the overall systems. So that's a bit of a game changer, and it's also a good group to interact with as far as building that whole value chain. We're looking at operationalizing research advances that can be advanced, but also sustaining some of the research advances like the class 4 metrics and so on, the verification, which is very important. Those are elements of this working group. And it's also an area where best practices in ocean prediction can evolve or be created or be also evaluated or tested out. So as I mentioned, we contribute to the Predicted Ocean DCC. 4C also engages with other elements of the value chain through dialogue and joint projects with the observing systems, also with CoastPredict and their activities there. The coastal part is extremely important for ocean prediction. It's really where the rubber meets the road as far as most end users are concerned. And a lot of the climate change and adaptation to climate change will be necessary is necessary in these coastal regions. And then also on the dissemination side, ditto, the digital twin of the ocean program, and end user engagement and capacity development. Thank you. That's the end. And the main thing is that this is the value chain representing it. And in all our efforts, it's, where do we fit in, and what is at the end of the day, the end user client benefit is what we're trying to achieve. Thank you. Back to you, Enrique.
Thank you, Fraser, for this very clear presentation. And it's my pleasure now to give the floor to my friend Nadia Pinardi. Nadia is a full professor of oceanography at Bologna University. And today she is representing here CoastPredict activities. I don't think Nadia really needs a presentation. Nevertheless, I will say a few words. She's one of the key figures for the development of operational oceanography in Europe. This is for sure. And she's an inspirational figure and a talented person that, very importantly, is leading a whole school of talented people that she has formed and inspired. So Nadia, the floor is yours to talk about CoastPredict.
Thank you, Enrique, and for the nice introduction. And it's very proper that we come after the important message of the regional systems and the global systems that OceanPredict and the DCC OceanPrediction is bringing to the right level of coordination and international recognition. We try to jump into where the ocean meets the people at the coast, and we would not be able to do that without the necessary downscaling approach and the necessary stepwise approach. So we are connected to the decade challenges, especially the number 6, which is increase community resilience to ocean hazards, since we believe, ocean hazards are felt everywhere in the open, from the open ocean to the coast, but we do think that we need, during the decade, to focus on the coast, which has been, the last one to come. And so that's the outcome. We want to have a coastal safe ocean. So a safe coastal ocean, that's better. And so we're connected to these challenges and outcomes, and we're trying to build implementation plans for demonstrating how this is possible. So CoastPredict goes to the heart of the integrated observing and predicting systems that wants to identify solutions. And our work is dedicated to risk, to the definition of risk for the coast, and managing risk and adapting as much as possible for the longer term. Adaptation, mitigation is also a component, but maybe other projects such as Ocean Vision or DCCs are dedicated to that, but adaptation is really a major issue for CoastPredict. So in fact, in order to think about how to deal with this problem, we needed to recast the ocean forecasting or the coastal forecasting issue into a multi-hazard risk endeavor, a risk management and assessment endeavor. And so we wrote recently a Vision 2030 paper where we, try to formalize the 3 steps: the risk assessment, risk reduction, the governance, and social transformation that are all required, together with coastal forecasting systems and new observations. So here we show an example of, it is moving, it will be soon, of what is now operational oceanography offering. Operational oceanography offers regional and global forecast, but they are not easily accessible. And this is a problem for us that you will see we will try to overcome. And we now have, in few places, real coastal forecasting system that enter into land as much as required. Because we believe the ocean is strictly connected to the land waters. Okay, so we want to also, we have a specific focus on nature-based solutions with the digital twins. And here, for example, is for seagrass, but we do it also for mangroves and others. And we try to find what is the technology and the science that is needed for examining the problem of defending our coast from increased storminess. We know we can find the solutions that are useful, but we need to have the digital ocean to help us to find these solutions to the best of our knowledge.
For the digital ocean, we always want to ask questions, and we want to find out how things are going to change, how climate's going to impact the things that we care about. So we need to ask questions. We need to have flexible, scalable solutions that allow us to address these issues. And the cloud gives us the opportunity to use whatever resources we need to ask whatever questions we need to answer, and not be limited just by the amount of resources that we happen to have on our local computers or at our HPC centers. So the cloud gives us the flexibility to really answer the science questions that we need to answer in a timely fashion. And it also allows anyone to ask these questions, not just the people with privileged resources.
So this is my friend, Richard Signal, and co-worker in much of the CoastPredict enterprise, which illustrated with his expertise, also expert judgment, one of the solutions that the decade has to bring to the people that are working in the science and the operational agencies is the cloud system as a data lake and a computing resource system. So we built an experiment in order to implement the cloud system that we need for the coast that we want, and to demonstrate the solutions, the different nature-based solutions or river outflow solutions. And we have envisaged a network of pilot sites where to do that. Design this innovative cloud computing infrastructure, and think about that at the end of the decade, we have enough best practices in these 130 pilot areas that we can probably deduce standards. Okay. So this is our global coast network. We started last year to collect from the research community. We have 130 pilot sites from 66 countries. And these pilot sites are coastal areas, are global coastal ocean, part of global coastal ocean regions, but essentially focusing on specific problems and hopefully solutions to be tried together. So the global coast experiment will be mainly the implementation of this new concept of a data sharing infrastructure and computing infrastructure at the end. It will be in a sequence that will overcome technological barriers, that will connect the work globally, enable public-private collaboration, replicable solutions and harness opportunities. So at the base of this global coast cloud digital infrastructure that we are building, there is the network with the research and the stakeholders in these experimental coastal areas, and a set of about 20 endorsed projects in the decade that have the experts for the different components. So I don't have much time more to tell you what that cloud will contain, but essentially it will take a mini ocean value chain for each pilot site to reproduce it for the specific solution and customized application that is required. So it will draw data from the global ocean when if that's the only one that is available, or from a regional ocean model, forecasting model, and observing system in real time. It will set routine multi-scale ocean predicting in the pilot areas and develop the customized applications. So this is the plan. We are working this year to make it a reality. And with the help of UNESCO, we are engaging into a large initiative that will implement this into the different areas. So my final slide, which is taken from a wonderful seminar of Professor Siders from Delaware University. How do we get the ocean that we want? Do more and eat veggies. Choose to adapt. Be creative and use the cloud. And thank you.
Thank you very much, Nadia, for this fantastic presentation. And there's a lot of things to learn from your presentation, and we hope that all this experiment will be a huge success. So all the best for this. And now we are moving to the second part of the. I would like first to say that if you have any questions, please use the Q&A box, and the questions will be addressed at the end of the presentation. So please, if you have questions for any of the speakers, don't hesitate in using the Q&A box. So we go now with, again, getting closer to the close with the regional teams. And our first speaker is the chair of the regional team of the OceanPrediction DCC regional team for the Med Sea and Black Sea. Manuela comes from the School of Nadia. She's director of regional ocean forecasting systems at Mediterranean Center on Climate Change in Italy. And she's in charge now of is deputy of the Copernicus Marine Monitoring and Forecasting Center, and co-chair of the Mongoose Modeling Working Group. And obviously, she's talking here today as regional team chair of the Med Sea. Thank you, Manuela. The floor is yours.
Thanks a lot, Enrique. Thanks for this introduction. So today, I will also highlight my role as co-chair of the Mongoose Modeling Working Group, because when we built at the beginning this regional team, the Mongoose community, Mongoose is the Mediterranean operational network for the global observing system that relies on the expertise of many people around the Mediterranean Sea. It was established in 2012 in order to foster the collaboration of these experts around our basin. So since the beginning, we have seen that this group was the has the natural role of participating and collaborating within the regional team for the Mediterranean and Black Sea. We have the possibility to link with additional sectors, also behind the science, and also to provide our support within the OceanPrediction DCC for the different tools, also establishing different connections with the other regional teams. So just a few words about this group. The modeling working group in Mongoose is composed by more or less 75 experts from 12 countries around the Mediterranean Sea and from 44 institutes, with several expertise, a wide range of expertise that we tried to somehow connect to the major topics that have been identified within OceanPrediction DCC, which are the different types of modeling from circulation, wave, biogeochemistry, and climate. And as you can see, we have a large part of our experts working in those fields, also several working in biogeochemistry and climate modeling, and more or less equivalent range of expertise between regional, local area modeling and coastal area modeling, but also experts in downstream services, capacity building, digital twin of the ocean, and also policy and legal aspects. So considering all these expertise, we have built our steering team last year, which is now fully operational, I would say. Not only from, say, experts from the Mediterranean Sea, but we also involved a community within the Black Sea. Actually, for the moment being, this community is mostly focused within the experts of the Copernicus Marine Service for the Black Sea, but we would like to enlarge this group. Here you see that we have identified at least one expert for each of the relevant topics for the ocean prediction. And we act as a focal point for our region, for sure, for these different topics. We are networking with other regional experts and providing new ideas, trying to map the ocean forecasting capabilities in our region and support the gaps and need detection, and of course, expand our community and support the capacity development and ocean literacy. What we have done so far, what actually we had our meetings, we actively tested and populated the atlas, which I will show in the next slides. Also trying to, we volunteered to support the forum and also provided several news and being also, let's say, participating in the Mongoose General Assembly and workshop that we have every year. So coming to the Atlas, actually this is a tool that we have tried to, let's say, populate as much as possible. This is a view of what we have at least up to Friday last week in terms of population of forecasting systems worldwide. And as you can see, the Mediterranean and Black Sea is one of the most populated areas, so meaning that our experts actively contributed to that. And actually, we have included, for the moment being, 64 systems, forecasting systems from 14 organizations. And you can see here the different areas where these systems are implemented. The bubbles raised show the, let's say, the domain. The larger is the bubble, the larger is the domain that is covered by the system. And now I'm going to show you a summary of several information that I extracted from the Atlas according to the information that has been included. Of course, it is not possible to go into details and show each of these systems. So that's why I try to summarize the major information in these next slides. So, so far, our community introduced the information on the forecasting systems that they are running, actually operationally. And they're based on 12 models, 4 wave models, which are the 60% of this cake. 7 circulation models are used by our community, and only 1 biogeochemical model, which is the biogeochemical flux model, is used. Our community is developing and providing forecasting data for regional areas, so for the entire Mediterranean Sea and for the entire Black Sea. but several are also providing forecasting system at the regional level, meaning sub-basin and area in different areas of the main basin. But most of the operational systems are local systems, coastal systems, and also running in gulfs and ports. Half, I would say more or less half of the systems are providing forecasting data up to 3 days, and the other half also provides forecasting data for more than 3 days, up to 10 days. Actually, all the Copernicus service, marine service for the Mediterranean and the Black Sea are providing 10 days forecast. And the majority of our system, as you can clearly expect, since most of the systems are local systems, are providing data at the resolution which is less than 1 kilometer, very high resolution from 10 to 1 kilometer. Most of these systems are also based on a structured grid models, which have the possibility to reach those very high resolution in specific areas. What we provide, this is the list of essential ocean variables that are provided thanks to these operational systems. Sea states, so waves, in this case, significant wave height, direction, and period, but a large variety of, the larger amount of ocean state variables that are provided are from physical models, currents, temperature, salinity, and sea level. And then there is this large bunch of variables that are instead output from biogeochemical model for phytoplankton, zooplankton, and organic matter. The systems, our expert, let's say, have identified several applications that can use the data that we provide. And you see here the list of applications. Most of them are for coastal hazards, research, port management, oil spill flight, and many, many others. So just to summarize the main messages, yes, for the Mediterranean and Black Sea regional team within the OceanPrediction DCC, for sure, Mongoose and the Copernicus Black Sea are the two main communities that are the core of this regional team, and that are providing a large community of experts. Our steering team has been established, started the meeting, and actively supporting the activities, all the activities within OceanPrediction DCC. We will continue for sure to improve and populate the atlas, also because this is an important tool for us to, let's say, understand where we are, to make, let's say, a sort of, to give a sort of indication of the modeling capabilities of our regions. And it is also a way to strengthen our collaboration and a way to support our ocean forecasting and its application in the region. Thank you.
Thank you, Emanuela, for this excellent work and presentation. Having a first view of the results coming from the Atlas is fantastic. So I really congratulate you for this effort, and the fact that the Med Sea is the best populated area in terms of the Atlas that is being born now. We are on the first stages of building this Atlas, but the fact that the Mediterranean is so advanced is a good testimony of the work that you have done on the regional team. So thank you very much for this. Our next speaker is, we move to the Africa regional team. Our next speaker is Jennifer Beige. She's a physical oceanographer, Head of Sustainable Ocean Modeling Initiative in the South African Environmental Observation Network, SAON. She leads an expert team for the development of Bay-scale operational ocean forecasts on key regions of South Africa integrated in the National Oceans and Coastal Information Management System. So, Jenny, the floor is yours. You are muted.
Thank you. Okay, so I should be audible now, and I just need to confirm that my presentation is in the right place.
Everything is fine.
Fantastic. Okay, so I'm going to take this opportunity to talk about African perspectives on ocean forecasting systems, the services they provide, and the need for best practices. And I'm really going to use a South African system as an example here. South Africa is relatively under-resourced, but far less so than many of our African neighbors. Challenges that we share are really the lack of in situ data, lack of infrastructure, bandwidth issues, but most desperately, it's the lack of human capacity or not enough human capacity. Let's also not forget about the challenge of our extremely turbulent oceans. So we've got a western boundary current system, an eastern boundary current system, but also the complicated interactions between the two. But this, coupled with a burgeoning offshore industry, sensitive and important ecosystems are really the recipe for disaster, unless we can provide adequate information about the changing state of the ocean that is provided in a way that can be easily utilized by end users. So to this end, the National Oceans and Coastal Information Management System was established by the Oceans and Coastal Branch of the Department of Forestry, Fisheries and the Environment. This, together with partners SOARS, SAON and the CSIR, has been established to provide tools for end users. For this to work, data is really key for making the informed decisions. And the shared knowledge allows for better coordination and responses to threats. So providing and promoting the sharing of data through the development of decision support tools, OCIMS is supporting many stakeholders in government, industry, and across the public sector. The aim is really to produce a system that is sovereign, but that is still integrated within global and regional networks. So the development of support tools is guided by stakeholders, with the primary mode of interaction with our major users being through formalized advisory groups, of which there is one for every decision support tool. The advisory groups consist of not only developers, but also users, and provides the platform for regular dialogue between these groups so that the tools that are produced are actually fit for purpose and are useful. So the users are also direct contributors by providing various data sets. And in this way, the OCIMS portal for me is really just an excellent example of an effective stakeholder co-design process. Currently, there's 8 decision support tools, half of which are operational and require constant data feeds. The rest are more static, and they really just provide data layers to support decision making. The success of OCIMS really depends on research and development in order to extract knowledge from data, the production of knowledge products via interactions with users, and collaborations and partnerships with multiple sectors that include academia, industry, and the public sector. But the foundation of it all is access and management of data, of quality data. And to this end, the DFFE has made significant investments to improve their data management practices. They have invested in both large IT infrastructure and data management systems, and have developed the Marine Information Management System, which is a system that was implemented in partnership with SAON and which is integrated with SAON's open data platform. And since about 2020, users can directly use the MIMS portal to search and download data. It has evolved over time into an international portal. It is an accredited data unit of the IOC and the national node identified by the IOC for ocean and coastal data in South Africa. It also hosts historical data of the South African Data Center for Oceanography, or SADCO, and is an AfroBIS node for sub-Saharan Africa. And MIMS, importantly, adheres to best data management practices and is designed with an interoperability focus so that we can ensure that the system speaks easily, with other portals across the world. So while OCIMS is a national initiative, there is strong synergy and collaboration with Mercator, which is an EU-funded project led by the CSIR, and it is helping with the provision of ocean services to many more countries than just South Africa. So I think I'm about halfway through and I haven't spoken about forecast services at all, but I think it's really important to share the context, which I think is actually quite sophisticated and healthy in terms of best practices into which our forecasts will be integrated. So a small recap of where we are in terms of our forecast system. Our approach was very simple. We developed two downscaled limited area forecast models, downscaled from freely available Copernicus forecasts and freely available but fairly low resolution atmospheric forecasts. They provide 5-day forecasts with resolutions that range from 500 meters near the coast to about 3 kilometers further offshore. We're quite happy with the results. Most of the time, in most places, they do better than the global products. In some places, they do even better than the state-of-the-art global products that are assimilated. So we provide a fairly sophisticated and fun user portal, which allows users to zoom in and out, have a look at the bathymetry, look at the MPAs. They can configure their color mapping, scale, and range. They can select their depth. They can select the variable. And then to select all the information at one point, you just need to click anywhere on the screen. So all this is quite nice. We also provide the outputs operationally via a thread server. Currently, tools are being developed to make all of the outputs CF compliant and therefore more interoperable. Additionally, we've added end user value by integrating an OpenDrift module to our workflow that allows us to provide forecasts of the trajectories of any oil spill, whether it happens inside our limited area domain or within the global forecast product that forces its boundaries. This has actually been extremely successful, and we've had emergency requests from various stakeholders that include the Maritime Safety Authority, marine legal practitioners, integrated coastal managers, and so on. So we're pleased to say that we've made a lot of improvements to the system. Our West Coast, our Southwest Cape Coast domain now includes the entire South African West Coast, so our entire Benguela upwelling system. We also are forcing it with high resolution atmospheric forecasts, courtesy of our weather service. Unfortunately, none of this stuff is being integrated into our visualization portal, and this is because our systems developer has moved on and we've been unable to replace him. And so we are at risk. We are really subcritical in terms of human capacity. And so in order to safeguard our system as it is, we are doing a few things. So the first thing is to publish our full forecast system workflow that is developed entirely with open source tools on a Git repo. That includes a detailed wiki, as well as to make it freely available. The system is also fully Dockerized for the ease of transfer between users. So this approach not only ensures the transferability of skills between system operators, but is also conducive to sharing our rather simple approach with others who wish to develop something as affordable. Also, in order to ensure our sustainability, we are doing ongoing capacity development and training, not only of students in the form of supervision and workshops, but also with our partners in our OCIMS consortium, just to make sure that we've got more than just one person who can run our forecast system. So our list of things to do is very, very long, but it will all be guided by best practices in order to support transparency, interoperability, open science, as well as efficiency. And we really rely on best practices developed by the community. And documents such as these that you see on the left-hand side there will really help us, along with effective collaboration and coordination with both local and international initiatives. This will really pave our way forward. And that's all I really wanted to share from Africa. Thank you.
Thank you very much for your very nice presentation, and congratulations for all the fantastic work you are doing in the region. It's amazing the amount of applications and work you are looking for. It's quite ambitious. Our next speaker is Sudhir Joseph. He's the chair for the regional team of the Indian Seas. Sudhir received a PhD at Indian Institute of Technology, and he works now at INCOIS as a scientist in implementing a hybrid coordinate model, the HICOM, for the Indian Ocean with data simulation capacities. So Sudhir, the floor is yours for your presentation. You're muted.
Thank you, Enric. I'm just sharing my screen. Hope is it visible now, the screen?
Perfect. Thank you.
Okay. Thank you. Good afternoon, good morning to all who are from different parts of the world. So I will be presenting a brief about the activities in the Indian Ocean region. And in fact, let me have first a recap of what happened after the formation of Regional Indian Ocean team. Actually, we had in 3rd of May 2023, we had the first meeting, and then terms of reference for Indian Seas was accepted. A steering team was formed formed identifying experts from this region. And also we could participate in the Toulouse regional meeting and participated in several online meetings. These were some of the activities I thought maybe it is good to recap. And OceanPredict TCC was represented in IOC 2024 in February. And Dr. Behra and Enrique were here, and they were able to be active participants for this IOC meeting. And in INCOIS and Mercator, we have prepared a draft document regarding joint collaboration in the field of operational oceanography, which we are, and particularly in field of digital twins. And if you look at the regional team, we have Dr. Ibrahim Khotait, who is from the King Abdullah University, the Professor Tawhida Rashid, he is the Director General of BORI, Dr. P.N. Vinay Chandran from Indian Institute of Science, Dr. Ashok Karamuri from King Abdullah University, Dr. Debaradi Sengupta from, she's an ECOP, and then she's from IIT Kharagpur, and my own colleagues, Sri Pattabhi Rao, Dr. Uday Bhaskar, and Nimit. In fact, at INCOIS, we run a suite of models, and the various products are generated and reach to the end users. We have the total value chain at INCOIS from generating the forecast to reaching it to the final end users. So our effort for modeling started with wave forecast, which was somewhat easier. And so we have started it with the wave watch initially, and we have come to the present stage in a stage-wise, phased manner. So we had first half-degree Indian Ocean domain, which is nested to a global 1 degree wave watch 3, and then a quarter-degree Northern Indian Ocean, and very high-resolution 4-kilometer coastal wave watch 3. And it produces a 10-day forecast of waves. And also it has assimilation, and we use ECMW forcing for running this. Basically, this forms a major part of our coastal, serves major coastal community from the Indian coast, because many a times the fisher folks and other maritime users, they get affected by the waves, which are not only originating locally under the influence of strong local winds, but there are waves, swells reaching from Southern Ocean to Indian coast, which makes sometimes sudden surprise watershed in the coastal region, because in the locally there may not be any disturbance in the atmosphere, but we see that all of a sudden the coastal region of particularly the west coast is inundated, and this causes a major concern for many fisher folks. Many times their boats and catamarans are taken away by this backwash of these waters. So then comes the next stage of our evolution was to look for a general circulation model. We have started with a GODAS, which is quarter degree, in fact, not quarter degree, it's having a varying degree resolution from half degree to quarter degree, which is global. And it has a data assimilation with 3D VAR. And then it is nested to a ROMS, which is 1/12th degree for the Indian Ocean domain, and with the data assimilation of LEDKF. And there is a further high resolution 2 kilometer northern Indian Ocean ROMS, but we could not put the data assimilation there because of the computational limitations. So basically the innermost domain runs without data assimilation, but taking initial and boundary condition from the outer ROMS, which is at 1/12th degree resolution. These are used, this is used for various purposes at INCOIS, including oil spill and others. We also have another model, which is the HICOM, which is quarter degree, which is set up at quarter degree resolution for the global domain. And it has a nested 1/16th degree Indian Ocean domain with a vertically 28 layers. And we are assimilating the along track SLA, Argo profiles, and SST. And this model basically is the highest resolution with data assimilation available for the Indian Ocean, Northern Indian Ocean. And we are presently recognized as the regional meteorological Center for Numerical Wave and Ocean Prediction. And in this is the web page where we are serving this. And basically the WaveWatch 3 predictions and HICOM are provided through this interface, and users can download the data on a daily basis, and it is being used by various users. And then we have these are the working horse behind us, but then we have several products which goes to the end users. For example, we are having demand from various stakeholders to provide the data in different formats, and also we provide high wave alerts for the coastal areas of southern India. And we also provide our services to neighboring countries like the RIMES countries, island countries, Sri Lanka, Maldives, Seychelles, Mauritius, Bangladesh, and all these countries we provide our forecast. And we also provide customized products for industries. For example, our oil and natural gas corporation, they needed forecast in a particular format and a specific region. So we are producing customized forecast for them. And also there are ports and harbors who need for their regional applications. So such specific products we are producing and providing it to these end users. Apart from that, we have also an emergency service. One among that is the oil spill prediction system. In fact, the end user can put the input what is the kind of oil, what is the source, location of the oil in the spotted, and then they themselves can run. This interface allows them to run the backend oil spill model, which is Genome, which is running at our server, but the end user has the flexibility to run this model themselves by providing the basic required information to the model. Similarly, another application is search and rescue operation for the Coast Guard. This is also an application where our general circulation model currents and winds are used in the backend to run a Lagrangian model. And the interface is there for the end user, that is the Coast Guard, to input the basic data, like where the object was lost, what type of objects there are, like almost like 64 kinds of objects which can be searched using this tool. So this is another service which we are providing to the end user. When we are interacting with users, one of the demand is that they are looking for impact-based forecasts rather than just essential ocean variables. Basically, what happens is that in case of fishermen, if we say that please don't go to the sea because sea is rough, some of them are having bigger boats. Some of them are going in catamarans. So basically, they are asking. Sometimes what happens? Their colleagues, they go and they come back safely. So they say that. So you are telling that there is a highway which is risky and you should not go. But there are our colleagues who are going and coming without any problem. So this kind of request comes to us, so that we need to have a special forecast issued for different classes of vessels which is going for operation. So we have developed a system where it uses an index called boat safety index, which gives different classes of boats, whether it is safe for that class of boat based on our model forecast and observation available to us. We give such kind of services to the end users, so that we are trying to keep their operations less impacted by the warnings, because sometimes what happens, this over warning kills the end users operations. So they are a bit upset about that. We are issuing warning frequently. Then some classes at least can go. Those who are able to go, they should be allowed to go. That is what their demand is. So we are working towards these kind of things, and basically we need to have several integrated components for that. One is the standard operating procedure, then decision support system, ICT tools, and also we should have forecast experts to assess each kind of situation. So basically, we have to end up giving a warning which is involving all the different kinds of hazards, integrating all the hazards at a given time. What are all hazards affecting the coast, whether it is safe for the end user to go for an operation at sea. These are some of the new developments happened at INCOIS. So we have earlier we were operating from different labs. Now we have an integrated operational lab, which we call as Synergistic Ocean Observation and Prediction Services Lab, where we have end-to-end system. We have observations landing here in this lab, which has a huge screen where it can be verified with operational products. And also we have all kinds of model outputs coming into the screen. Daily operations are happening from there. There are 24/7 operational staff looking at the forecast products and verifying it with the help of observations. Some of the challenges are that maintaining these observation systems in the current situation. So we are working towards maintenance of this observation system more efficiently. This is another recent development which happened with the collaboration of INCOIS, NOAA, IMD, and NCMWF, and some of the Indian institutes, which is the basic objective is to have a coupled model for the Northern Indian Ocean, where when we have high impact and highly dynamic events like cyclones or strong monsoon, kind of variability. So basically, severe weather, when it happens, we need to have a much higher resolution, because we run the ocean model with a forcing of lower resolution. So sometimes we are not able to represent the processes properly in the ocean. So we have a nested setup where these nests can move around. And we can place this nest. For example, if there is an oil rig here and we need to have a high resolution ocean forecast for that region, we place this high resolution nest, which can be up to the 1.5 kilometer. It can place on the area of our interest and produce high resolution atmospheric forcing and provide the forecast with the lesser expensive way rather than running for the entire basin. So this is the setup which we are working towards, and we hope in near future we will make it into an operational system. And this is another area. We have recently inaugurated our Marine Energy Atlas, and I am keen to see what other regional teams, if there.
Sorry to interrupt you, but if you can start finishing the presentation, we are running.
Yeah. Sorry, this is the last slide. So I'm curious to know about if any of the other regional teams are working towards marine energy extraction. And thank you very much. Yeah.
Sorry, I speak 2 seconds before time to tell you that. Thank you very much.
Thank you
for your excellent presentation. And our last speaker for this session on the regional team is Swadin Behera. He's the chair of the regional team for the West Pacific and marginal seas of South and East Asia. He's a leading scientist in global ocean and climate research. Especially, he's known for discoveries of several modes of tropical and extratropical climate variations, such as IOD and IOSD. And I have to say that very recently he was honored as Union Fellow by the American Geophysical Union. So, Swadin, the floor is yours. You are muted.
Okay, can you hear me now?
Now it's perfect.
Yeah. Thank you very much, Enrique, for your kind introduction. Good evening, everybody from Tokyo, Japan. Can you see my slides?
Yes.
Okay, thank you. I'll talk to you about the regional team of Western Pacific and marginal seas of South and East Asia. As you all know, this region is very rich in biodiversity, not only terrestrial biodiversity, but also marine biodiversity, and also for its fishery, from small scale fishery, individual fishery, to large scale industrial scale fishery, and the trade routes, energy resources, and the climate, the typhoons, the cyclones, and those kind of extreme events. So in order to develop sustainable development strategies, we need to kind of enrich this region with very nice operational forecasting systems. And there are several forecasting systems already available in the region. I'll show you one or two examples here. It is very difficult to cover all the all the countries' operational systems. So I'll just present one or two here. However, still a lot needs to be done because there is a large diversity among the countries' operational level, operational readiness level, and the systems available to them. So the OceanPrediction DCC and this regional team kind of work together to develop a better system, and which should be available to all the countries in the region. To improve the user experience, also to improve the research, and most importantly, by using the digital twins framework that Enrique presented in the beginning. To show you one example, this is the example from my center, my group here. This system is called JCOP, Japan Coastal Ocean Prediction Experiment. Although it is called coastal, it is not coastal. It is kind of semi-global from 60 south to 60 north. The course resolution model is 10 kilometer, and the finest model is 200 meters. 200 meters model is available all around the coastal regions of Japan. And the idea is to, once we kind of fine-tune this model and get the best possible results, forecasts, we will try to replicate that in other regions. There are several use cases already being used for several applications, ocean applications, from fishery to marine renewable energy and the seaprout and oil spill. Similarly, NMEFC, National Marine Environment Forecasting Center, based in Beijing, China, they also have their own model, which can be from several kilometers to tens of meters in special scales. So all these systems are global. There are also some regional models in Korea, in Indonesia, in Thailand, in Malaysia, in Philippines. All those operational systems are working. And the idea is to kind of integrate all of them if possible, or at least prepare a best practice method. Enrique first authored a paper already kind of cataloging what is available in the region, not only in this region, but all the regions in the world. And then what are the models available? What are the operational systems available? So we have some understanding now. The next stage would be probably to kind of develop a framework under the OceanPrediction DCC with all the regional hubs. One side we build the community, the other side we prepare a technical framework which can be available to all the countries and the stakeholders in this region, not only in this region, but all the regions under OceanPrediction DCC. On the community building side, you have the Atlas, you have the wiki, news, forum, meetups, and user community. The user community in this region is not so large compared to the Mediterranean region you saw earlier, but it's growing. So hopefully we'll have more operational centers and other modeling centers get into this Atlas so that we have a better idea of what are the things available in this region. On the technical framework side, as I told you, there is a large diversity among the centers. So that's why the framework of 3 different kind of frameworks available to us. The first one is just ocean modeling with a smart interface, which is almost available now to everybody. The next one is to integrate digital twinning to the kind of output stage, or include that from the beginning, so that digital twin takes care of everything from like data assimilation to user end information systems. So we'll try to see which system is good for which country, and probably depending on their available infrastructure and capacity, they will probably adopt one of those. And eventually we'll try to see how it is working and prepare a kind of best practice method for each of them, and somehow integrate them so that everybody have a similar kind of output. The community development in this region, we already have a big community and a big group under this regional hub. And then we try to address all those topics listed here. There is a good steering team, more than 15, I think close to 20 members. And then there is a bigger group members. And hopefully each of them will try to contribute to each of those topics. And eventually we try to merge all those ideas to develop the desired goals we are facing now. We hold regular meetings. Already we have 2 meetings in last year, and this year we had a meeting in June 25 online, and we discussed several topics from what we did in the Ocean Conference in Barcelona to what we want to do in the next years. Several of us also participated in the Ocean Decade Conference in Barcelona. Also, I participated particularly in the side events, which was organized by Enrique, and we discussed in the panel discussion, we discussed what are the gaps and what we should do to fill those gaps. Then we also had a regional ocean conference in Bangkok following the Barcelona meeting, and several of us were also attending that. We also had several workshops and sessions. I think Eileen was holding several sessions, I was holding one session, then we both were in a town hall event, and we try to promote the ocean prediction activities, not only numerical ocean prediction, just physical oceanography, but also ecosystem modeling and predictions. This is the plan for this next few months in this year and also next year. So we'll hold a regional online workshop sometime in December and January to update each other what's happening and how to further enhance our collaboration. We are trying to discuss 1 or 2 topics where we can share the information, share the data, and also collectively get a kind of warning system that can be used by all the centers. One of them could be like the marine heat wave early warning system. I was in NMEFC a few months ago, I think in July, and we agreed that we can develop this system and then kind of invite other centers to participate in that. Then we plan to hold an on-site workshop sometime in May, June next year. Hopefully, many of you will join this one here in Tokyo. And then we are developing a work plan to support the user community. As I said, we are also trying to kind of identify 1 or 2 key topics which can be addressed by all the centers so that we can have some integration among the centers. That's all. This is summary. Like we all know that the forecast systems are evolving. We are quite good now to give operational forecasting in this region. However, a lot to be done, and OceanPrediction DCC provides us a nice framework to integrate all the system and find good solutions, identify the gaps and find the good solutions for those gaps, and improve the capacity and ocean literacy in the region. I'll stop there. Thank you.
Thank you very much, Odin, for this excellent presentation and the good presentation of plans ahead. This is fantastic, and I really like very much this initiative and these plans. So I don't know if we have any questions, any new questions on the box. I don't think we have any open question because questions have been replied during the presentation. So I would like now to have some discussion with the chairs of the regional teams, and I would like to launch you some questions, and please feel free to interact and to drift away from these questions. It will be great if we have a very a dialogue like not fixed to rules. So I would like to start, since we are on a meeting we have just 12 minutes for this, so I'll go to the core. We are on a meeting about best practices, and I would like to have your view on how best practices, of the role of best practices in ocean forecasting, and what is the expected benefits that we could have for from a better management and better, let's say, implementation of best practices in ocean forecasting. So I will leave the floor open to anyone that wants to jump, and if not, I will choose with my finger.
Yeah, let me start. I think the paper said before, which you kind of first authored with many of us in that, the best practices for the operational readiness level, identifying what are the ORLs and how to implement them. I think many centers will find it very interesting and very useful. And hopefully we can do the same thing for like end user best practices. What are the indicators we should use? And how do we identify the best we can provide based on the stakeholders' needs? Probably we can have some common needs, and then we put some index. Okay, for this need, if we are able to give forecast 2 days ahead, 3 days ahead, 5 days ahead, then we give some point to that. And then also evaluate how good is our forecast and how the stakeholder takes our forecast. Sometimes we feel, as a scientist, we feel our predictions are not so great. But for user, maybe that information is quite useful based on their own understanding, because they don't have any information, and then they get some information from these systems. And we need to identify, okay, what is our side indicators and what is the stakeholder side indicator, and then integrate them to find the best practices for that. The ORL is very nice. I think it is going to be very useful, not only for preparedness, but also how the models are integrated, how the systems are operating, whether they are good for providing operational forecast. In that sense, I think it's very good. Thank you.
Thank you, Sorin. That was excellent, and you opened the floor to a new field that we have to really think to launch very somehow provocative ideas on how we have to move forward in the future, and we have to reflect about this, because it's true that we need to continue this virtuous loop, and the part that is less developed is the one related with integration and applications. And this is exactly what you're saying in your sentence, that we have a good ETUFS guide, we have an architecture, we have an ORL, all this is well described now, but we're missing this last step, which is the one related with the integration, the digital twins and the applications. And we have to think on how to approach this world, because it's huge by definition. Okay, and we have to work with our colleagues from FORESEE, from CostPredict and other decade programs so Suder, you are trying to jump, I think.
Yeah, in fact, I was trying to say that after that overall work has come out, I started looking at our own system, and I think when you were here, I showed some of those things. So basically, we have to maybe informally send this overall document to other forecasting center and see how best they are fitting into this this 1 to 5, 0 to 5 grading. So maybe that will kind of, each center will have their own specific approaches, and that may not fit the definition whatever we are defining. So that kind of, interaction may be good to have a refined, or maybe we have to refine operational systems at each center, or maybe if it is that time, if it is required, maybe we have to define the overall framework accordingly. So that anyway, it is best practices defined as of now, but there may be some here and there changes because of the specificity of each operational center. So that's something I was thinking of telling you.
Thank you. I think you are quite right on this, and I'm sure that the ORL will have, let's say, evolution and future versions. And while we start using it, we will learn a lot about it, and probably we will need to end at the end with a more flexible tool. I think this is version 0 or version 1, as you want to call it, and I hope it will be very, very useful.
Can we? It is very useful. Can we have a kind of initial round, round with all the centers who are participating to have assessed their own system assessed in terms of this ones, and some kind of grading, so that we will have an idea about how is it practically working.
Okay, two comments to this. First of all, the paper is about to be published. It's not yet published.
Okay.
So we have to wait a little bit, because one review, we have 3 reviewers who were okay from the beginning, saying this is excellent. The third one gives some minor reviews. We address those minor reviews, and we are waiting for a final confirmation to have it published. And once this is done, we can approach, we can disseminate this so it is used. But I would like also to tell you that during the process of the preparation of the operational readiness level, we did something like that, because at the beginning, when we believed everything was more or less ready, we put that into test, and we received let's say, a humble lesson that our writing was not that good or that perfect, and we did an iteration with several operational centers, and it was very, very funny, because every center we did this application of the operational readiness level. The next one had lesser problems, the less one less problems, the less one less problem, and the final one was okay. I understand all the points. This is good to me now, but it needed some iteration, as you are suggesting. But nevertheless, I'm sure that we are far from perfect, because this is quite ambitious. And also, that is true is that there are things that must be more detailed. They are not sufficiently detailed on the document, and we have to go into. I mean, just to give you an example, there's one condition there that says systems must be protected against cyber attacks. Okay, what is exactly that? And you can write a whole book about that. So the level where you stop is important. So let's give time to maybe Jenny or Emanuela to comment on this. Who wants to jump?
I can give a brief comment. Yes, you were asking about the benefits from ocean best practices. I guess that there are a lot of benefits in applying ocean best practices in operation ocean forecasting, also to improve the reliability of our forecasting data. But also we will have the opportunity to increase the reliability of the existing operational system, but also to give the chance to other areas of the world where we have not this kind of, let's say, mature forecasting systems to grow and to somehow try to balance and have a more homogeneous coverage of ocean forecasting systems around the world, thanks also to ocean best practices, if we can advance on that, yeah, all together.
Thank you, Manuela.
Thanks, Emanuela. You told my story, because I 100% agree with you. You know, coming from a more under-resourced part of the world, best practices really, really help us. You know, we can do things the right way from the beginning, learning from the experience of others. I think I alluded to it also in my talk, that because we're so subcritical with regard to human capacity, it's really important that everything we do is interoperable and clear, and that we follow best practices, because if we lose some people, the next person can easily, in theory, take over the system. So for under-resourced nations, best practices are really, really important. It will ensure that no one's left behind moving forward. Thank you.
Thank you. I think this is a good point, and we are really 2 minutes away from finishing, so I don't think we have more time. We have Nadia that wants to share with us. Please, Nadia, go ahead.
Yeah, sorry, very briefly, just to add one more point to all the others that I totally share. I think that would help under-resourced countries, or anywhere, you know, country that wants to start to do operational forecasting, to start to have research institution interfacing with their Met offices. That is a sustainability requirement, in my opinion, that we should consider when we advise people to develop. So it would be great that in your DCC Ocean Prediction, you show the available agreements with Met offices to do the work that we do in the regionals and the global.
Thank you, Nadia. This is a very interesting idea. We have certainly to explore, and I agree on the importance on connecting with the Met offices, and also learning from the world of meteorology. We have one single system, which is the ocean atmosphere. It's one system, and I sometimes, in fact, in terms of operational systems, we have a lot to learn from the meteorological world that is quite advanced.
Not only, we did also the atmospheric forcing.
Exactly.
Okay, so
you're very philosophical. Yes.
It is exact time. Thank you to all of you. I think it was an excellent discussion, and a little bit too short, but okay, that's my fault, not your fault, for preparing a very packed agenda. As I don't, I have no solution. I will never learn to do an agenda which is not packed. I'm a lost chaos. So thank you very much to all of you. Fraser, nice to see you now again, and thank you for all the people staying with us until the end, and see you next time. Bye bye. Thank you.
Bye-bye.